So, hello everyone. Today we're going to solve this question longest increasing subsequence. So, let's just copy this example onto our board and discuss what does the question says. Let me just make it a little big so that it's perfectly visible. That's it. So, like if we are given this example with 10, 9, 2, 5, 3, 7, 101, and 80. So what do we need to do? We need to know the longest increasing subsequence. So what's the longest increasing subsequence in this? Just remember, this subsequence is not subarray. 537, this is subarray, but 53 and 101, this is subsequence. But like it's not increasing, it's decreasing. So let me take increasing subsequence as 3 to 7 to 111. That's an increasing subsequence. Subarray as well, it's subarray as well. And 9, 109 and 101, these two are increasing in, so they are subsequence. So what do we need to do? What's the longest subsequence? Let's just check one by one. If we start from 10, so what do we get in increasing? This 1, 2, and this 2 as well. If we don't consider this, we can take this as the increasing one. And again, if we start with 9, so what greater than 9? uh 101 is greater than 9. Yeah. 18 is greater than 9. What else? If we take 2, yeah, 1, it's also 1. So it becomes 2, this becomes 2, this becomes 3. If we even if we consider just 3, 237 or 257, so it's greater. Yeah, it's greater. 237. Okay, 237 and 101. So this is third, and if you consider this, it's 4, and this is well 237 101 237. In fact, 237 and 18. This is also of length 4. So this also becomes greater. I mean, like this also like having length of 4. So this is long, one of the longest increasing. So we are done until 2. So we've seen. Now if we move ahead, so 5, 3, 5 and 7 becomes 1, becomes 2. Let me just erase all this whatever I've written. And 5, 7, 2, second, third, and this is also third, because 101 is lesser than 101 is greater than 18. We are considering 18 the longest increasing subsequence, so it's 3. And similarly for 3, it's 1, 2, 3, and 3 as well, because again the same thing, that 18 is lesser than 101. 7, 101, and 7, 80. So the longest we found was 237101 or 237180. So we got to know that 18 was the greatest, like 4 is the greatest number that we get for increasing subsequence. So how can we even solve this? What's the logic that we need to take into place? So uh, yeah, like let me just erase this first, and I'll let you guys know like what logic can you go for with solving this up. Okay, so yeah, like first you need to make a db array, and like the this should be of length. Firstly, all of them should be having value of 1, and this should be of length n. Suppose n is the length of array, length of array. Again, now the next step is you iterate for I 1 to n, so it will go until n minus 1 if you iterate from 1 to n. And next step is to iterate from for j 1 to I. Okay, you go from 1 to I. Suppose you are at I equals to 3, I equals to 3, 0, 1, 2, 3. Then you have to move from this place, this place, this place to one place before this. It means you have to check all the numbers that come before 5, that come before 5. So what comes before 5? 10 comes before 5, 9 comes before 5, 2 comes before 5, and for each of them, you have to check which one is lesser. Which one is lesser? It's as simple as that. And now comes the crucial step. dp of I equals to max. Remember, you have to find the longest, so we take max. dp of I comma dp of j plus 1. And when you're going to do this step is going to done if array of I is greater than array of j. Okay, array of I is greater than array of j. Then you're going to do this step, and at the end we are going to return the max of dp, the maximum number from dp array. So if array of I is greater than array of j, if suppose like 11, suppose we take 101 and we're sitting at 101, right? And uh, we will be pre-computing everything that's done beforehand, because we will iterate one by one, and there are two loops. So let me just show you how this works. Remember that if you can just go and try run this. Let me take a smaller array, and first just oh, okay, before taking a smaller array, let me just do it. dp equals to 1 into n for I in range and for j in range I if r of I is greater than r of j. That's all it is, because I was going to explain this part if r is greater than r of j. But it's intuitive. You can think of it if like the number at the very end which you're comparing to is greater than this, then you're definitely going to increment 1, because it's greater than the number you are calculating for, right? And we are going one by one state, so we'll be tracking like which number is greater and how many numbers are greater from the past digits that we've encountered. So we'll write dp of I equals to max of dp of I comma dp of j plus 1, return dp, or return max of dp. And if we run this, okay, I think this is the len of nums. I didn't actually change the digits, that the variables that I took, and explaining you the question. And this is going to be nums instead of array. nums instead of array. I think I'm right until here. Again, then of nums. I think it's good until now. So let me run this and we'll get the result here. Yeah, it passes, beats 94% memory and beats 54 in runtime. And this is exactly what I was trying to convey, that we'll be storing the number of digits that are going to be greater, like from which the current element at the very rightmost position we are iterating is greater to, and this is how it be done at every stage, at every iteration. So this was it from this video. I'll see you in the next one with another question.